Welcome to solverfy.
So now we'll work on problem 74 from chapter 17. In this problem, we're told that a solution of sodium sulfate is added dropwise to a solution that is 0.01 molar in barium 2+ and 0.01 molar in strontium 2+. What concentration of sulfate is necessary to begin precipitation? And we're told to neglect volume changes, and it gives us the KSP values. Now this also gives us two other questions. It asks us which cation will precipitate first, and what is the concentration of sulfate when the second cation begins to precipitate. So we can go ahead and calculate for barium and strontium the amount of sulfate that's necessary to start precipitation, and then we can answer all three questions at once. So let's go ahead and write in the KSP values for each of these compounds. So KSP for barium is 1.1 times 10 to the minus 10. And for strontium sulfate, the KSP is equal to 3.2 times 10 to the minus 7. So for barium, we can calculate precipitation will start when Q is equal to KSP, which equals 1.1 times 10 to the minus 10. Now this equals the concentration of barium, which we're told is 0.01. molar. And then we multiply by the concentration of sulfate, which is SO4 2-. And we solve for the concentration of sulfate, and we get 1.1 times 10 to the minus 8 molar. We can do the same thing for strontium. Q equals KSP, which equals to 3.2 times 10 to the minus 7, which equals same concentration as we had for barium for strontium, times the concentration of sulfate, which gives us the concentration of sulfate necessary to start precipitation for strontium sulfate is 3.2 times 10 to the minus 5. So the first question is, what concentration of sulfate is necessary to begin precipitation? So for question A, we can see that it should be the lower concentration from the two that we just calculated. So it's 1.1 times 10 to the minus 8. For B, they ask us, which cation precipitates first? Now we could have, we know that this should be barium based on our calculations because the lower concentration of sulfate is needed to start precipitating barium sulfate. And we could have guessed this based on the value of the KSP, since they're both a 1-to-1 ratio of the ions and they have the same solution of the cation. But we went ahead and did all the problems so we can answer all three questions at once, although we could have done B directly from looking at the KSP values. And then also the last question is, what is the concentration of sulfate when the second cation begins to precipitate? And that we calculated already as being 3.2 times 10 to the minus 5 molar.